Okay, now we're recording. Okay, so no fractions, no decimals, right? All right, now we got a fraction in the way, so we're going to get rid of it. And I think yesterday we said to do what here? You said times both sides by what? 5. So hopefully you understand why I picked 5. Why did I pick 5?
That's the denominator.
The denominator is 5. We want to get rid of it and multiply by 5. We'll do that. But what will it do here?
5y.
You'll get 5y. What will it do here?
2.
Yeah, see, this is 5 over 1 times 2 over 5. The 5 here will cancel. And all that's left is what? 2x. And then get the 5 back because it comes back for another try here. Negative 15. Okay? Good? Okay. Guys, the fractions are gone. But what we don't have are x and y on the same side. So now our job is to do that. I don't think I said this to you because the bell rang. In the back of your book, they will always put the answers, but your answers will always have the x term positive. So if that's already positive, where do you think we want x and y to go? On this side or on that side? That's it. Okay, so move this over here. How? Minus 5y knocks out the 5y, correct?
So that it's 0.
Minus 5y. Okay. The 15. We need it to come to the other side. How? Add 15. That knocks out the minus 15. And then we got to add 15 here. I'm sorry, this is really messy looking. All right. Now we want to clean it up a little bit. Here we go. There's a 15 over here, right? Okay. And 2x here. Now take away what? 5y. And there it is. Okay? Does that make sense?
Yeah.
Now, why did I want the x and y to be on the right side?
Because the 2x was already positive.
Because 2x was already positive. Leave it positive. Because in the back of the book, the x terms will always be positive. Now, wait a minute. There is another version of the answer. The other version would be, what if the x term was over here? What if the y term was over here? And what if the 15 was over there? So I can write this word. Or, the other version of the answer is,
Negative 2x plus 5y equals negative 15.
yeah, everything is basically opposite of what you see. This 15 would be what?
Negative.
Okay. So when I correct your test, I have to know that. So if you have my answer, I go, they get credit. But if you don't have my answer, you better have what?
4.
What?
4.
Yeah, I know, but what's the other? What do you think I'm looking for?
Okay.
Opposite. If I have 5x, you better have negative 5x. If I have negative 2y, you better have positive 2y. You get what I'm saying?
Mm-hmm.
So when I correct, I have to know that. What I'm saying is there's two versions of the answer. Okay? Just do this. Please just get the x term positive. Because then when you look in the back of the book, it's going to match. Okay. This one. What's in your way right away? Decimal. Okay, so if you got a decimal in your way, okay, now we got to do something to get rid of the decimals. What?
Times 10.
What?
Times 10.
Times 10. If you multiply by 10, you make a number 10 times bigger, which basically moves the decimal where?
1 spot to the right.
1 to the right. Okay. But wait a minute. What if this would have been, watch this, what if this would have been 6, 1?
100.
Multiply by 100. Because then you got to move it 2 places. What if it's 6, 1, 2?
Oh, my bad.
Multiply by 1,000. So whatever you want to move the decimal, that many zeros. 3 zeros will move it 3 places. 4 zeros will make it move it 4 places. Okay, so we have to move it what?
10.
Just 1 spot. So we're going to multiply by 10. That would give me 10 more. That's an easy one. What's this one? 91x. What's this one? 36. Good?
Yeah.
Well, I mean, good so far?
Yeah.
Okay. We don't have x's and y's on the same side. So what do we want to do?
Move the y to the right.
Okay. So you're telling me 91x is positive. Let's just leave it there, right? Bring the 10y over. How? Subtract 10y. Okay, how do you bring the 36 over here? Add 36. And you end up with 36 equals, this is gone, yeah? Okay. Decimals aren't too bad to work with, they really aren't. You know what some people do to fractions? When they see fractions?
Simplify.
No, you know, here's what they do. Some people take fractions, they just convert them to decimals, and then they multiply by 10 or 100 or 1,000. So you know what we did up there? I mean, we could have converted those fractions to decimals and then just multiply by 10, 100, 1,000, whatever. If you don't like fractions, you can get rid of them quick. Okay. So are we okay? With standard form?
Mm-hmm.
Okay, next page. This next page, just so you know, it's just review. Just a little bit of review in the beginning. It says when you are writing equations of lines, there are how many ways to do it? 3 different ways. First way you can write the equation is in what form? Slope intercept. Y equals mx plus b. Here's a very, very popular form, but this form is only used when you know what? A point and a slope. And usually when you put it in this form, you convert it back to that form, correct? Okay. Then there's another form right here. It's called standard form. You just did this on the previous page. Okay? So how many ways are there to write equations? 3. Typically, that is where you start. Start here, convert there. They could ask you to convert that way, but usually they don't. Okay? Good enough for review, I guess. Let's go here. Now, they're gonna go after standard form now. Listen to this. You can graph an equation in standard form quickly by determining the x, y intercepts and then drawing the line through them. Here's what should have made your eyes go up a little bit. You can graph standard form how? Quickly. Aren't you kind of interested? I can graph quick. I want to know how to graph quick because they're going to tell you right now. By determining what?
X and Y intercept.
If you can find the x-intercept and the y-intercept, plot them, connect them, you got a line. It's cool. Now, here's a picture of what I just said. If you can find the x-intercept right there, the y-intercept right there, you can graph a line quick. Okay? Now, why is that called the x-intercept? It's where the line crosses the x-axis. Why is that called the y-intercept? Where it crosses the y-axis. Okay, here's something you should know about the x-intercept. It's just a point. But there's something special about that point. What's special?
The second number has to be a 0.
Yes, because it could be 2, 0, 4, 0, 6, 0. This number has to be 0. This point, the y-intercept, what's so special?
First number has to be a 0.
First number, x has to be 0. So you find the y-intercept or you find the x-intercept. How? By plugging 0 in for x and y. That's how you do it quickly. Okay, let's do this one quickly. Okay? If I asked you to solve that, which you can't see, so hang on. Okay, if I said solve that or graph that, you probably would solve for y, pick out the slope, pick out the y-intercept, and then graph it. But it says here x, y-intercept. So why don't we try that? So how do you get the x-intercept? You find x, but the x-intercept will always have 0 for y. Plug it in. Plug that 0 in for y, solve it for x, and you got the x-intercept. That's all you have to do. So if I did that, 3x minus 2/3 times what?
0.
Equals, right? Now, do I really have to put 0 in? Doesn't 0 do what to the coefficient?
It just puts it to 0.
It makes it 0, so this is just gone. There's nothing here, guys. So really it says 3x equals what? Negative 12, or better yet, divide by 3. You get negative 4. So what's your x-intercept? Negative 4, 0. Where does your line cross the x-axis? Negative 4. Okay. Good. All right, what am I missing? I'm missing this one, the y-intercept. What's so special about the y-intercept? Every x value is 0. Every time you do it. This is always going to be 0. So, change your colors. Let's do this. Put it in for x right here. So that would be 3 times 0 minus 2/3 y equals negative 12. Okay, what's this?
0.
I didn't even have to write it, although I did it, but I didn't have to. I could just do this. Solve this equation. Negative 2/3 times y equals negative 12. How do you want me to get rid of that negative 2/3?
Times both sides by 3, or is it negative?
Depends on what you want to do. Okay, you're telling me to multiply this side and this side by what number? 3. Is that smart, guys, to do that? You want me to do negative 3?
Can you just...
I can do 3 or I can do negative 3. If I do negative 3, what's a negative times a negative?
Positive.
I get positive 2y. Okay. It really doesn't matter. I'll just stick with your 3. Even though I agree, negative 3 would be easier. Watch that. Out with the 3's. Those are gone. What's left? Negative 2y equals, but you got to multiply this side by 3 also. And you get what? Good. Divide. Opposite of multiplying? Division. Division by what? Negative 2, negative 2. What is it? Yeah. Half of 36 is 18. Negative, negative? Positive 18. That stands for the what? Okay, we got. Okay, so we go 0, 18. And then we have to do what? Graph it. Now here's the problem. 0, 18 falls where?
Oh, yeah.
Yeah, that's 10. So what do you want me to do? What?
You just go.
You'd go
Change your scale. Change your scale. What?
Change the scale.
Change the scale to what? What do you want me to count by?
2.
2s? Okay, you got to tell the teacher. You got to tell me. I'm going by 2s. If you don't say a word, I assume you're going by 1s. So you got to tell me. I'm going by 2s. I'm going by 4s. I'm going by 5s. I'm doing whatever. But tell me. 2, 4, 6, 8, 10. 2, 4, 6, 18. There's 18. There's negative 4. There you go. How's that? Yeah.
So like you can, even though you didn't go by 2s.
Okay. That I should have said that. Do I have to go by 2s and 2s? No. When it comes to the x-axis, if you write nothing here, you write nothing. I'm assuming you're going by what?
1.
You never have to say I'm going by 1. Never say that. Once you change the scale, you have to tell me. So I'm going by 2s. Here I'm going by 1s. Could I went by 10s on the y and 5s on the x?
Yeah.
Yeah. You can do whatever you want. Just tell the teacher what you're doing. Because the person who's correcting your paper has to know what you're counting by. And it doesn't have to be 2s and 2s or 5s and 5s. It can be anything. 20s and 50s. Whatever. Are you okay? Is this easy? I actually did a little too much work, if you ask me. What I usually do, just so you know, when I want the x-intercept, you know what I do? I cover up the y term. Divide by 3. What's the answer? Here, negative 4. When I want the y-intercept, I cover up the x term. And then that's a harder one. That's harder to do. You'd have to either divide by negative 2/3 or do all that work we did. But I don't really do all that, and I don't expect you to either. Okay? But I do show a lot of work up here. Okay? All right, this next problem is for you. I'm not going to say much. I'll do it, but I'll do it in a minute and a half. Would you please read it? It's 1 or 2 sentences. Fill in the table, graph it, see if you can get to the answer before me. You got a minute and a half. Right here.
0 days is past.
Where's Gavin?
I'm floating.
You're good.
That's all.
It's so easy.
Yeah, yes. I'll try to do it.
Just don't overcomplicate it.
Oh, yes, it is. Okay, here we go. Hey, did you pick out some important information on this one? The office manager of a small office ordered how much? Yeah, so this is all she ordered, okay? She's got 140 packages of paper. Next up, based on the average daily use, she knows that the paper will last only what?
80 days.
She knows that the paper lasts only 80 days. Okay, what graph represents the situation? Read the table. The number of days, if we're on day 0 versus day whatever, and this says packs of paper being used. The big word was what?
Used.
Used. So 0 days go by, how much paper have we used?
0.
None. We haven't used any paper. Right? If you look here, it says we've used all 140. How many days did that take?
80.
Okay? Slide on over. Before that, this is usually what column?
X.
X is, Y's. So the x-axis would be known as what? Days. You probably want to say days. This would be paper what?
Paper used.
Used. Okay. So 0 days, nothing being used. Right here. 80 days go by, 140 packs of paper being used. So that's about how the line would look. Okay? Is that what you did? Okay, maybe you did, maybe you didn't. I don't know. But that's kind of you just reading it, making sense of it, and there we go. And that was a good break for me, because I got to say your names and hand out your name tags. Okay? All right. Next part. This is it. Last part, and then we're done. We got 2 things going on. Parallel lines, perpendicular lines. Tell me, parallel lines, picture right here. What do they do?
It never
This
ends.
one's
What do
Never
they
once.
not do? They never intersect, never touch. Okay, that's parallel. Something you're supposed to know about parallel lines, right here. M1 equals M2, what's that mean? Same slope. That's what you should know. Whoa, that was weird. Same slope. Okay, same slope. That's what you have to know. And I think you know that. You can see they go at the same rate. So the slope wouldn't change. These are called perpendicular, which means they form what? 90 degrees. Okay, and if they form 90 degrees, they're perpendicular no matter how you position them. But what you need to know is right about here, M1 equals negative 1 over M2.
Reciprocal.
Or basically this. It says negative reciprocals. I'd rather have you guys say opposite. So if I'm you, I'm going to write this instead. Okay. Now, slopes. Slopes are opposite, reciprocals. Reciprocals, okay. Now, let me give you a quick example. If I went, slope of my first line is 2/3. What's the slope of my second line that's perpendicular?
-3/2.
Opposite of positive? Negative. Reciprocal would be what? 3/2. Would you agree that that's what that says up there? Opposite, reciprocal? Okay. When you go into a problem and they say perpendicular, you got to think opposite, reciprocal. When they say parallel, you got to think what? Same slope. Okay. Now, here we go. If there's anything that's going to mess you up on the first quiz, it's this. Because most of the time, you guys just don't understand what's being asked. Problem 3. What is the equation? So I want you to write me an equation in what form?
Slope intercept.
Slope form, or slope intercept. You will write me an equation like y equals 2x minus 3, like that. Of the line, I wish it would have said of the line parallel to this line going through this point. How many people right now? Raise your hand. That makes 100%, you're 100% clear on what that's saying. Okay, that's pretty good. Last period I got about 2 hands. This period I'm getting about 6 hands. To me, when they talk about parallel lines, I go like this. I draw. I'm very visual. I want to know what they're saying to me. I have 2 parallel lines, and one of them has an equation of what?
4x plus 2y plus 7.
Right? So I put it on one line. Okay? But you're supposed to write the equation to this other line. But your other line goes through this point, 4 comma what? Yeah. So here's the deal. How do you write equations of any line? You need to know what? A point and the slope.
We already know the slope.
How do you know the slope?
Because it's parallel.
But what's the slope to this line?
4x.
You need to put it in.
Oh, negative 4.
No,
Two
you
and
need to put it in slope intercept form.
Gotta solve it for y before you take the slope. See? That's the tricky part. You gotta solve this for y. So now take this equation over here. Do your work. Show your magic. Here we go. 4x plus 2y equals 7. Now solve it for y. Then take the slope. Some of you are daydreaming. Okay. Get out of that trance. It's 2 in the afternoon. Come on, snap out of it. Solve for y. Move this over. Right? Minus 4x minus 4x. Okay. Now what? Divide by 2. Once you divide by 2, you get
Negative 2x plus 3.5.
plus 3.5. Okay. The only thing I care about is the slope.
Negative 2x.
Slope is what?
Negative 2x.
Don't say x.
Or negative
It's just a number. It's negative 2. Everybody agree that that's negative 2?
Yes.
What do you think your line has a slope
-2.
of? -2. They're parallel. It has to be the same. So your slope is -2 also. Now you have to write the equation to this line, given this point, given this slope. So now what form would you put it in? No, you can't. Point slope. You'd have to go point slope. Okay. Okay, so you go point slope. So here we go. Let's change the color on you. Let's go black. Point slope would be y minus, what's the y value out of these two?
-2.
Slope is -2x minus what? 4? Okay. Distribute through, right? And you get, what's this going to be? Y minus -2 is +2. This is
-2x.
+8. Yep. Okay. You're almost done. Get the y by itself. Subtract 2. Y equals what?
-2x +6.
Okay. There it is. Now remember what the problem said? It said write the equation to this line, not this one, this one. So this answer goes with this line. That's the answer. Okay, you were only solving for y to steal the slope. That's all you did that for. Okay? This will be on YouTube, the last example. You need to watch it.
Yeah.
Okay? YouTube. All right. Where are you going by that?
Crookston.
Crookston. Take those pirates down. Okay? Do not let the pirates beat you. All right. Okay. That's not helpful. Okay. Okay, let's do it again. This time, we're talking about what kind of lines?
Perpendicular.
Perpendicular. Why don't you do yourself a favor? Draw perpendicular lines right now. Okay, and I'll try to make this bigger. There, that's better. So you're going to draw perpendicular lines, I hope. One here, one there. Put a little box here. Okay? This really doesn't matter, but where would you put that equation? On which line?
It would be on the one that's going up.
The one that's going up. How'd you know?
Because the slope's positive.
2/3 is a slope, it's positive. Why wouldn't you put it on this line, right? So here you go. You have a line going up with an equation of 2/3 x minus 1. You want to write the equation to the other line, this line, okay, with a point of what? 0.6, okay. There. Well, you're missing something on this line. You're missing the slope, aren't you? So what's the slope of this line that's perpendicular to this line?
Negative.
Okay, you guys, you have to understand, that's in slope-intercept form.
Yeah.
Steal it, but don't steal it. Do what to it? Flip it,
-3/2. Make it negative.
and change the sign. Yep, so it's negative what?
3/2.
Okay. How do you write the equation to this line now that you know a point and a slope? Point slope form?
Y.
Do it, just do it. John, just do it. Just do it. No daydreaming. I'll give you a 30-second head start. Point slope form. Ten, 9, 8, 7, 6, 5, 4, 3, 2, 1. Boom. Raise your hand if you did not do point slope form. Everybody out there did point slope form and then solve for y to put it in slope intercept form. Okay. Did you recognize this? Here's the slope. Did you recognize this point as anything special?
0.
0,6. Where would 0,6 fall? It's the y-intercept. Guys, you know what you had? You had the y-intercept in front of you the whole time. You had the slope in front of you the whole time. Guess what you could have done? Y equals slope, negative 3 over 2x,
Oh.
plus what?
Oh.
6. Did you do point slope form and get that anyways?
Yeah.
Yeah, so it doesn't matter, does it? No, but I was thinking one person would say, wait, you don't have to do point slope. You have the y-intercept, you have the slope, you can just write it. Didn't matter though. If you did all the work, you did it right anyways. If I did the work, you should have done this, right? Y minus what? 6 equals negative 3 over 2. X minus what?
0.
And that's what? Yep. What's this? Nothing. Don't write it. Okay, y minus 6. How do you move the 6 over?
Yeah, 6.
And once you get here anyways?
Yeah.
See, you guys did too much work. You didn't have to do all that work. And in math, sometimes if you can make connections quicker, you can get the answer faster, and then you feel better instead of doing all that work. Okay. But no big deal. We have about 3 minutes, and then in 3 minutes, we're going to grab a book. We're heading to the library, and the period's over. Okay? So you don't have much time to work. How many people did not pick up the blue worksheet yesterday? Okay, here's people. So you have 12 problems. Here we go. If you didn't pick it up, here it is. If you picked it up, just let me know.
We have a classroom set up next week and bring every day.
You will need to bring them the days it says on the calendar. You have an assignment in your book. Otherwise, you're going to sit there and go,
Say no classroom set.
I don't usually put them on.
Yeah.
Okay. Yeah, I'll get the blues. I'll get the yellows. I feel like almost everybody needs this, right? Do you have one? Yes, you can. You're excused. I'm listening. Oh, I hear you.
Yeah, I know it's not.
Who's checking?
I've never been there.
Did I miss anybody? For the blues? For the blues? I got the yellows coming in. Okay, sorry, there's no time to ask me questions with the yellow. But listen, please. Listen.
Yes.
You guys, this is a tough class. Some of you will not have much trouble all year, but the majority of you will struggle. You need to understand I'm here at 7:30 in the morning. That's a half hour in the beginning. And I'm here every night from 3 to 4. And if you can ever match up with me during the day, come and see me. This is not an easy class, okay? Just so you know. All right? All right. Yellows, I don't want to collect them. You put them right here. Put them on my stool. Go grab a book. Head to the library. Give me the yellow. Go grab the book. Go to the library. Get your name on that book.
Oh, Mr. Ritter,
Yeah.
where do you want these?
Oh, I can collect those.
Okay.
Whoa.
Sorry. And I can use diagram for you.
Yeah.
It's totally new thing
Why lunch?
I'll carry it. You will.
Is it something you have to or want to?
I never can finish it. I don't know if you care or not, but
How fast do you drink?
not very fast.
No, because is it like a cold? Is it a cold kind of drink?
Yeah. Well, it's really thick. Oh, thank you so much.
Okay. Oh, so it just doesn't go down. Wow.
Yeah.
The only reason I hesitating is I could care less, to be honest.
Yeah.
It's just that when you do it, then the next student thinks, well, then I can have
Oh,
one.
yeah.
You know what I mean?
Yeah.
That's the only reason. Otherwise, if you were in college, do you know that in college you can do almost anything you want?
Yeah.
You could just bring it or have lunch and you They
Yeah.
don't even care. But see here, then we run it. School policy says if you're gonna eat the class. So I'd rather have you not,
Okay.
but I'd rather have you. I'll just say it that way.
Okay.
I don't mean to be mean to you. I'm
No,
sorry.
no. I was just wondering because I wasn't able to last year either, so
Yeah.
I just wanted to make sure.
Yeah.
Okay.
Thanks.
Thank you.
Yeah.